Welcome to Chapter 17, 17.5 IV flow rates based on body weight per time. So many infusions administered to the critically ill patient are ordered by an amount based on the patient's weight for a certain length of time period, and this is written as amount, patient's weight, and time. Alright, so the amount, patient's weight, and the time. Right. So, for example, heparin is calculated in units per kg per hour. So, units per kilogram per hour. Alright, so the procedure checklist, which is 17.3, found on page 520, is the following. Define the flow rate based on weight per time. So, first thing, convert pounds to kilograms, if needed. Convert the units of measure of the dose on hand to the same unit of measure as the dose ordered, if needed. Calculate the desired dose. Two ways to calculate. Convert unit of measurement of the desired dose, if needed. And then lastly, calculate the flow rate in milliliters per hour. Alright, let's take a look at the first example. Example 1. Find the hourly rate at which to administer dopamine to a 220-pound patient. Ordered, we have dopamine 5 micrograms per kilogram per minute. And on hand, we have dopamine 400 milligrams per 250 milliliters normal saline. Alright, okay. So first thing we need to do is see what we have and then convert if we need to. Alright, so the main thing to notice is that the weight has been given in pounds. So we need to convert from pounds to kilograms. Alright, so first thing, convert. Okay, so we have 220 pounds. We want to know how many kilograms that's going to be. So as usual, we have our conversion factor here, 1 kilogram, 2.2 pounds. So let X be the number of kilograms. Going ahead and cross multiplying, we'll end up with X is 100 kilograms. Alright, so the patient weighs 100 kilograms. The next thing we need to do is see what else we need to convert. Let's take a look at what has been ordered and what we have on hand. Alright, so what's ordered is we have, oops, wrong pen. Ordered is micrograms and we have milligrams. So we're going to have to go ahead and change that. So we're going to convert from milligrams to micrograms. And the conversion factor we have for that is 1,000 micrograms is equal to 1 milligram. We'll go ahead and set that up. We want to figure out how many micrograms we have. So X over 400 milligrams. Cross multiplying. And I'll go ahead and work this one out. We get, changing pens, X equals 400 milligrams times 1,000 micrograms all over 1 milligram. We can cancel out, 1 microgram. No, that was milligram. Cancel out the micrograms, milligrams. Ooh, too many grams happening. Cancel out the milligrams. We'll be left with X equals 400,000 micrograms. Got it right that time. Alright, so we know, let me go ahead and erase some of this down here. So then we have, because there was 400 milligrams in, or per, 250 milliliters, we know therefore that we have 400,000 micrograms in 250 milliliters. Alright, so lastly, now we're going to go ahead and calculate. We've done all the conversions, so let's go ahead and do the calculations. Okay. we need to figure out the desired dose of dopamine. To do that, we'll use the formula we have in the third step, which is unit of measurement, unit per kilogram per hour times kilogram, or the weight in kilogram, which would equal our dose. Okay, so the unit we have is 5 micrograms per kilograms per hour times, and the patient weighed 100 kilograms. We found that out by converting the 220 pounds. And what does that equal? Well, that is going to end up equaling, the kilograms will cancel each other out, and we'll be left with 500 micrograms per minute. Alright, so the next thing we want to do is convert the unit of measure of the desired dose. And the desired dose that we want is in terms of micrograms per minute. Okay, and we need to calculate micrograms per hour. So we're going to have to convert micrograms per minute to micrograms per hour. And to do this, we're going to multiply by 60 minutes over hour. So let's go ahead and take right here the 500 micrograms per minute. And we're going to go ahead and multiply that by the conversion unit, 60 minutes in 1 hour. And what do we get? Well, the minutes will cancel out, and we will be left with 60 times 500, 30,000 micrograms per 1 hour. So the desired dose is 30,000 micrograms per hour. All right, we're on our way. We're almost there. Okay, let me go ahead and just remove this one piece for the last step. Get rid of that. All right. So the last step is calculating the flow rate in ml. Okay, so to do that, we're going to go ahead and use our formula, which, if you recall, is going to be HQ dA, and the dose on hand was 400,000 micrograms. The unit was 250 milliliters, and the desired dose is 300,000 micrograms per hour, all over, and A, the amount to administer. Okay, so, ooh, that got a little tilted there. Multiplying all of that out, we get, so cross-multiplying, 40,000 micrograms equals 30,000, oh, that's times A. Boop. Multiply that in. Running out of space. Okay. Micrograms per hour times 250 milliliters. Simplifying that, we get A equals, the amount to administer is 18.75 milliliters per hour, which is the flow rate, but we need to round this to the nearest tenth, which would then be 18.8. So, the flow rate is 18.8 milliliters per hour. Large number of steps there, but everything so far has built up to this. Okay, let's take a look at the next rule. Rule 17.5. So sometimes it's necessary to convert the rate from milliliters per hour to milliliters per minute. to verify a safe dosage period, since there are 60 minutes in 1 hour. To calculate the rate in milliliters per minute, you divide the rate in milliliters per hour by 60 minutes per hour, or multiply the rate in milliliters per hour by the conversion factor 1 hour per 60 minutes. So let's take a look at an example. If the flow rate is 18.8 milliliters per hour, then the rate in milliliters per minute is calculated as the following. Okay, I'll show two options here. First option. So you start with the 18.8 milliliters per hour. Go ahead and divide this by the 60 minutes per 1 hour. When we do the division there, we'll take the reciprocal. And the hours will cancel, and we will be left with our answer, which is 0.31 milliliters per minute. Or the other way we can do it is just go ahead and start with the 18.8 milliliters per hour and times it by the 1 hour per 60 minute. This way is much simpler than doing the division, but in our textbook they showed the division, so I decided to show you the division. That's going to go ahead, multiplying that out, we'll come out with 0.31 milliliters per minute. So probably easier to just go ahead and do the multiplication first, but there would be times when it's advantageous to use the division. Both methods work. Best thing to remember, minutes and hours, or hours and minutes. You can take the reciprocal of those fractions and use them as conversion factors. Always good to have that trick up your sleeve. Alright, so the next rule. If you know the total amount of medication in the total volume of solution, as well as the amount of solution that the patient has received, then you can use a proportion to calculate the amount of medication the patient has received. Alright, so hopefully this is changed on your notes by the time you get it, but small typo. That should just be another parentheses, not dosed. Alright. And then you have the proportion total amount of medication over total volume of solution, all over amount of medication received over volume of solution received. Alright, so we have our example 3. A pregnant patient has been given an increasing rates of Pictocin to induce labor. Since her arrival at the hospital, she has received 50 milliliters of a solution that contains 20 units in 1,000 milliliters per LR. Alright, how much Pictocin, not entirely certain that's how it's said, has she received? Alright. So what we know is the total amount of medication is 20 units. And the total volume of the solution, so total amount, oops, wrong color. Units. And we know that the total volume is 1,000 milliliters. And lastly, we know that the volume of the solution received was 50 milliliters. Volume received. Okay, we can go ahead and set this up in our proportion. So volume received is going to be on the bottom here. Volume of total solution, and then total amount. So let's go ahead and set up our proportion. So 20 units over total volume, 1,000 milliliters, equals amount of medication, which we don't know that one, so that's what we're trying to find. X, amount of medication, over the 50 milliliters. Okay, so now we can go ahead and solve by cross-multiplying. We get 1,000 milliliters times X equals 20 units times, 50 milliliters. Go ahead and cancel out the milliliter units. So 1,000 times X equals 20 times 50 is going to be 1,000 units dividing by 1,000. We'll go ahead and get that the patient, well, X equals 1 unit, sorry. Jumping the gun there. So the patient has received 1 unit of Pictocin. Pitocin. Oh, Pitocin. Interesting. Alright, there we go. Pitocin, Pictocin. Swapping those here. Alrighty. Moving on. I believe this is the last example. So your patient is receiving dopamine titrated to maintain his blood pressure. His infusion started with dopamine 800 milligrams, 5DW, 250 milliliters at a rate of 5 milliliters per hour. Over the last 3 hours, you have titrated the dopamine up to 12 milliliters per hour to maintain the blood pressure. He has received 122 milliliters of the solution. How much dopamine has the patient received? So we want to go ahead and fill out, or find the information we need to fill out the proportion. So let's see, the total amount of medication, what is that? Well, the total amount of medication is 800 milligrams. Then we need the total volume. And the total volume is 250 milliliters. Lastly, we are going to see what else we have. And we have the volume of the solution that was received. He received 122 milliliters. Okay, we can go ahead and plug this into the proportion once again. So we have on top 800 milligrams over the 250 milliliters. Total amount received. And then the amount we're trying to figure out, which is the amount of medication received. Okay, we can go ahead and cross multiply. And we get X times 250 milliliters equals 800 milligrams times 122 milliliters. Go ahead and cancel out the milliliters. Dividing by the 250. And let's see, we get X by itself. So we have 800 times 122 divided by 250 milligrams, which is going to end up equaling X equals 358.4 milligrams. Alright, so our answer is the patient has received 358.4 milligrams of, and what was he receiving? Dopamine. Period. All right, and that is it for this section.